Let's just see how this thing rings a little bit here. All right, let's see what this thing actually weighs. I've got it on this scale. I'm not really sure how accurate this scale is, but I hit these corners with a file here a little bit. There's actually going to be a radius here. I just didn't put it in the program. I was trying to minimize the size of the program because the machine's memory only is 500K. Well, actually only about 420 because of the Renishaw probing programs and everything in the memory. And so I have to kind of try to reduce the size of these programs, or I could run a DNC drip feed, but I don't really like doing that. I'd rather just upload the programs in smaller programs into the control. But just to do, you know, this cuts on the side here and this 3D thing takes a lot of memory, and I actually had to kind of increase the step over here, but it's not too bad. This says it's 1/1000th of an inch cusp height, so I don't know, maybe. But I'm trying to keep the programs down to about 400K so I can get them into the control. So I'm having to break them up. And like I said, I filed these edges a little bit just so they weren't so sharp. I didn't want to cut myself when I'm handling this thing. But so far, I don't like this this cycle here that I used to face the top of this angle. This faces here. It left a little bit of a bump in the middle, but it'll polish out with the Scotch-Brite wheel. All right, I'm trying to make this as smooth as possible because I want to engrave the logo in here. And this is actually very smooth right here, the way that end mill faced it with this end mill I've been using, this 3/4 inch with an 1/8 inch tip radius. I've been doing all of this with. And there's faster ways to face this with bigger tools, but just to make the programming simple, I just use this same tool to do everything here on this. And down here, I'm going to come in from the other side with a 1-inch carbide end mill, and I can just barely reach this distance. This is about 5 inches here, and I have it's actually a ball nosed end mill, but it has a long cut length, and I can just let the ball nose hang out beyond and cut this and all the way up the bottom of this horn. The reason I had to 3D the side of this horn, let me get a square just to demonstrate this. This isn't a 90-degree angle here. See, it's you know, I don't remember the exact angle. It might be 10 degrees or so more. And I did that on purpose because sometimes when you're actually forging something, you want to bend it further than 90. This forging's become magnetized a little bit. I don't know if you could see earlier in the video how all the shavings are just kind of sticking to it, and I can feel it with this square. It's like almost I can feel the magnetism just a little bit. But if you look at that, I don't know if you can see that. You see the square. This isn't square, so I couldn't just turn this. I know people will ask, see, that's square, but this isn't. And people will ask, well, why didn't you just rotate the 4th axis and face that? But it doesn't work out that way because it's not 90 degrees or straight up and down, so you can't do it. I could have done it if I was on the Mazak, tipping the B axis, but I'm not over there. Although I might take the whole thing and chuck it in the forge-out chuck down here and get it running true to put the square hardy hole in here, because I can do a shaping cycle much nicer on the Mazak as I did with the small anvils. So I might do that with this. Now all I have to do is come in from this direction for the horn, and I'm going to just pretty much do a 3D thing all the way around the horn, kind of like I did with the roughing face mill or the feed mill. And I'm going to put inserts with an 1/8 inch tip radius, which is the same as what this end mill has here. And I'm just going to come in straight in from the end of the part all the way to the face here. First, I'm going to cut this kind of cut over here down as far as I can go here with this end mill. I'm going 3 inches, 3 1/8 actually, because of the tip radius. I got to go to get 3 inches so that I can have 5 inches from here to here. I can cut with the, well, let me get the end mill, I'll show you. I'm going to have this end mill in the toolbox, and it will, it'll make this cut length. The tip of it's kind of messed up. It's a little bit gnarly on this ball nose right here, but I don't need that for doing this cut. Finish isn't super good. I had to kind of, in order to fit the program in the machine, I had to reduce the precision of the cut. Here I kind of set it down a little bit so I could face the top of the face off and not hit the horn like I did on the little anvils. right, you can see that we've turned the fixture around here to do the, I want to face the sides and cut these radiuses and do this, surface this angle right here because it's just rough right now. And I'm going to do this in kind of what might seem kind of a strange way, because when I did this horn and then I recut it, I went just a hair deeper into this face. And so I had to rerun this finish pass right here on this end mill coming in this way. And I cut about 4 or 5 thousandths more off of this space here, coming in here with this space mill, because I set a negative finish allowance to kind of recut this horn a little bit, because I wasn't happy with the finish of it the way I did it before, and I had to rerun it with a DNC drip feed, if you will, because the program turned out to be 5 megabytes in size, and this machine only holds 400K, well, about 400 to 500. It's about 400 and, I don't know, 50K in the memory with the Renishaw probing cycles in there. If you took them out, you'd have about 500K of memory, is all this machine has in the working memory. So in order to run this finish cut on this horn, which has many, many step downs, and all of this is little short line segments, because this horn here isn't round. It's not just a conical shape where you can use arcs to go around it. It's got all different kinds of radiuses and stuff on it, and even the top of it is flat for a small area right here. So it breaks this up into a bunch of little line segments, and the first time I ran it, I had to, in order to get the program to fit in the memory of the machine, I had the resolution set such that it would fit, but it left a lot of little facets, and I didn't like it. So I reran it, and I put a negative 10,000 stock allowance on it to cut it 10,000 smaller. And I kind of forgot about that would make it go down deeper into this face when I did it. I wasn't thinking to restrict the depth of it, or to actually maybe offset the tool path out a little bit, because it was going to also go into the face more. So I cut a little bit more off this face than I wanted, but it's not critical. We're not working to any kind of set dimensions here. So what I'm going to do is run my end mill, that long ball end mill I described earlier, to try to finish this down to this level, so it's 5 inches deep here. And this ball end mill will reach, but it's probably going to give trouble. We're going to see about that, but I'm going to run it just as is with my fixture offset set the way it should be. And then I'm going to measure my step here with a depth mic, and I'm going to set the fixture offset over a little bit and rerun the finish cut of it. All right, let's see what this thing actually weighs. I've got it on this scale. I'm not really sure how accurate this scale is, but anyway, we're gonna do it. And we got the 200-pound weight here. And the thing is more or less balanced, as you can see there. And we're up to 51 1/4 pounds, so around 250 pounds. It'll lose a little bit of weight when I cut the hardy hole in it, a couple pounds maybe for that, but it's gonna be around 250 pounds. The CAD software said it would be about 270 something, so maybe I had the wrong gravity for the steel in there, or maybe I cut a little more off than I had in the model. But anyway, that's the weight. Let's just see how this thing rings a little bit here. Well, it rings like an anvil. I'm gonna face the top off of this yet, so that's why this is still got these roughing marks on here. I got to take about 10 or 15 thousandths off the top here.